On this episode of Vtuber Presents, I, Blueberry, will be talking about matrix multiplication. So what is a matrix? A matrix is an arrangement of stuff in a rectangular table that contains various amounts of rows and columns. The stuff in the table can represent numbers, symbols, variables, and elements, and here are some examples. What is matrix multiplication? It is the multiplication of two matrices or a scalar value. This operation produces a single matrix called the matrix product, and matrix multiplication is also known as the dot product of two matrices. So here we have two matrices, and you can multiply them with each other, or you can multiply it with a single value, which is a scalar value. And we will get into that right now. So, matrix multiplication by scalar value. So what is a scalar? It's a single number, and it relates to a concept in linear algebra called vector space. For example, it has magnitude but no direction. So basically just note that there's only one value, and that this relates to value being in vector space. So a scalar value can be represented by an S, and a matrix can be represented by a B. In the example on the left, so this example right here, the scalar value is 5, so in this case S is equal to 5. B is the matrix, and in this example, B is a 2 by 3 matrix. To read the dimensions of a matrix, look at the number of rows as your first value. So here we have 2 rows, and then look at the number of columns. So here we have 3 columns. So this matrix is a 2 by 3 matrix. To calculate y, which is the product of the two, multiply the scalar value to all matrix values. So multiply 5 to all the values in B. So we have this matrix showing that. So we have 5 times 1, 5 times 2, 5 times 3, and then same for the bottom, but the other way around. And this is our result. Once you get the result, you can check if it is the same dimensions as B, as the final matrix product should be the same dimension as B when multiplying by a scalar value. So we check y is indeed 2x3. So yay, it looks correct. Next, we have multiplying a matrix by another matrix. First, let's look at the two matrices. We have one here and here. Look at the first row of the first matrix, so A1 and A2, and look at the first column of the second matrix, so B1 and B3. Well, this is where it gets a little bit complicated when saying it out loud. You multiply the first number in the first row of the first matrix, so A1, and you multiply that with the first number in the first column of the second matrix, which is B1, and then you add a value with the second number in the first row, so A2, times the second number in the first column, so B3. You take those two values and you add it, so that's how you get the first value in this matrix. And then you repeat that for all rows and columns. So if I were to find this value, I'd get A1 times B2 plus A2 times B4. If you're still confused, don't worry, there are more examples, and these examples should help. So here we have example 1. So we look at the first row and the first column. You take 1 times 4, and then you have 2 times 2, and then you add those values. And then you continue on to the second column. You do the same, 1 times 1, 2 times 3, so that will be this value. And for these two values, you go to the second row. So you go 3 times 4, and 4 times 2, and you add those two, and then 3 times 1, and 4 times 3. So once you get this, you simply multiply and add them out. So you get 8, 7, 20, and 15. And that is your final answer. So that is your matrix product. And in example 2, you do the same process. Even though that these matrices are not the same dimensions, it's okay. just do the same process. You have 5 times 1, 3 times 2, 2 times 3, and you add them so you get this first value. And you go to the second row, do the same, so you multiply 1 for all of them and then add them, and you do the same here. You take these values, you multiply them for each value like this in the column, for each value in the column, and then you add them all. Once you do this, you get these values, and then just find what these are. You just add them, and then you get 17, 6, and 11, and that should be your final answer. Here we can check matrix multiplication. Something important to note is whether or not you can even do matrix multiplication. When you have two matrices, in this case I'm going to use A and B, the number of columns of A should be equal to the rows of B, and this is called the dimension property. I will quickly go over properties in the next slide, but let's focus on this specific example. So here we have two matrices. We'll call this A and this one B. So if we say that the columns of A, so 2 columns, has to equal the number of rows of B in B, the matrix B. So we have 2 rows right here. So they are equal to each other, and then we can solve it. And over here we have 2 columns and 3 rows. So they're not equal to each other and they are incorrect. So we can't do matrix multiplication for this. Matrix properties. A property is a characteristic that applies to a given set. In this case, the given set is matrices and matrix multiplication. So the first property is distributive property. So if you have 3 matrices, let's use this bottom one as an example. You have A times B plus C, so the 3 matrices, and then you can distribute A, so you can have AB plus AC. And that should equal each other. Next property we have is the multiplicative property of 0. We have A times O, or O times A is equal to 0. So O is representing a 0 matrix. So a 0 matrix is just a matrix with a bunch of zeros. So when you multiply them together, it will equal 0. And then the third one is the associative property. So here we can move the parentheses around, so you can have A times B first and then multiply by C. However, it's also equal to BC first and then A. So they are equal to each other. That is the associative property. And here are some more properties. So we have the dimension property. As I have mentioned earlier, the columns of the first matrix, which in this case is n, has to equal the rows of the second matrix, which in this case is n. However, you can also check the product, the answer, the result. So the product should equal the number of rows of the first matrix by the number of columns of the second matrix. So if your answer to a matrix multiplication question does not equal this, you probably made a mistake. Actually, you made a mistake. There's no probably. This is a property, so it holds up to all cases. Another property is the multiplicative identity property. So we have the identity matrix, which looks like this. You have ones going in a diagonal across times a matrix. So when you multiply it by this identity matrix, it should equal itself. And the sixth one is actually not a property, but you should note, it's a note, that matrices are not commutative. So AB does not equal BA. When you switch them around, it doesn't always equal each other. So, good thing to note that this, despite all these other properties, it is not commutative. Also, I'm just a VTuber, so please do your own research. I could be wrong on stuff. I just like sharing math stuff because I find it interesting. Yeah. Thank you so much for listening to my presentation. Like and subscribe if you want to. Thanks for watching. Beep boop. Okay. Bye.